Alright guys, here's a video on binomial expansions. So what do we mean by a binomial? Binomial is something like a plus b to the second. And it would be nice if we could say that's a to the second plus b to the second, but it's not going to work out that way. And the reason why is because when we talk about a plus b squared, we're really talking about a square that is a plus b wide and a plus b tall. Now that's going to give us an a squared, which we have. It's going to give us a b squared, but it also gives us these other regions. And so really what this will be is a squared plus 2ab plus b squared. Now for the same reason, a plus b cubed is not going to be a cubed plus b cubed. And this is going to be a three-dimensional figure. This guy right here is going to be our a cubed. This one right here is going to be our b cubed, but we have a bunch of other regions. So what are those regions? Well, the way we talked about it last class is you just do it manually. It's just a lot of plugging and chugging. So if we have a plus b cubed, that's a plus b times a plus b times a plus b. And if we evaluate just the first two terms of that, we end up with a squared plus 2ab plus b squared. But then we got to take that and we got to multiply by a plus b. Now when you do that, you're going to get a bunch of terms. You're going to get a cubed plus a squared b. And then let's take this one, and that's going to be 2a squared b. And that's going to be plus 2ab squared. And then we're going to get this one, and that's going to be plus ab squared, and then plus b cubed. And when you clean that up, when you combine the like terms, you get this expression. You get a cubed plus 3a squared b plus 3ab squared plus b cubed. And you can see how this becomes pretty difficult, especially if you have something like a plus b to the 6th, a plus b to the 7th, and so on. But you'll notice we have a pattern here. A plus b to the 0th is just 1. A plus b to the 1th is just going to be 1a plus 1b. And you'll see why I'm writing those ones there in a second. That's going to turn into 1a squared plus 2ab plus b squared. A plus b cubed, as we saw it, will be 1a cubed plus 3a squared b plus 3ab squared plus b cubed. And if I did the next one, and I did this out the long way, we would have this. We'd have 1a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. And if I only focus on those numbers, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Forget everything else. Let's just draw those numbers again. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6. And now see if you can see the pattern. How am I going to get the next number? Well, these guys add up to be 15. And these guys, 10 and 10, give me 20. Those guys give me 15, those guys give me 6, and we put a 1 down there. And then for the next layer, well, 1 and 6 is going to make a 7. That's going to make a 21. That's going to make a 35. That's going to make a 35, 21, 7, and 1. So this whole pattern is called Pascal's triangle. And now we are in a good position to solve something like this. A plus b to the 6th. Instead of doing this out the long way, we're going to follow the pattern 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4. Oh yeah, I did that wrong. 3, 1. So we got 1, 4, 6, 4, 1. We got 1, 5, 10, 10, 5, 1. We have 1, 6, 15, 20, 15, 6, 1. So we have the coefficients And let's write the coefficients out. We're going to put some space in between them. 1, 6, 15. We've got 20. We've got 15. We've got 6. And we've got 1. Now here we've got A. I'm going to write A in blue. We've got A. Let's write this guy in red. This guy is going to be B, 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 B. And you'll notice, let me go up here. You notice this pattern with the exponents. You've got 3, 2, oh, I made a mistake there. No, I didn't. That's right. There's an invisible 1, that's a to the 1th, and there's a little a to the 0th. So 3, 2, 1, 0. Here you have 4, 3, 2, a to the 1th, and then a to the 0th. So we're going to follow that same pattern here. We've got a to the 6, 5, 4, 3, 2, 1, and 0. And with the b's, we're going to start with 0, 1, 2, 3, 4, 5, 6. Now let's go ahead and clean that up. And that's going to turn into a to the 6. That turns into 1, and we can forget about it. Plus 6a to the 5th, b, plus 15a to the 4th, b to the 2nd, plus 20. You can just copy these guys down exactly the same. A to the 2nd, b to the 4, plus 6, a, b to the 5th, plus that last one is going to be b to the 6th. Okay, so now how do we use that to solve something like this? Let's say we have 2x minus 3y to the 4th. Let's go through some steps here. Step number 1, Pascal's triangle to get the coefficients. So using Pascal's triangle, we got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So Pascal's triangle, we're going to write the coefficients, and we're going to give ourselves plenty of space here. So we're going to really space this out here. We're going to write 1, 4, 6, 4, 1. Now, the next step is we are going to write each term by each coefficient. Now, what do I mean by each term? By each term, I mean this is a term and this is a term. And each of those terms gets copied by the coefficients. So this guy has a 2x, and they all get the 2x. 2x, 2x, and this guy gets a 2x. They also all get this term. Now this term includes the negative. Don't forget the negative. Super important that you bring that along. So we got negative 3y, negative 3y, negative 3y, negative 3y, negative 3y. Next one is we're going to do the exponents. And the exponents, we're going to count down from we start with this guy. We start with 4, 3, 2, 1, 0. And this one, we're going to go from 0, 1, 2, 3, 4. Now, if you add these up together, 4 and 0 make 4, 3 and 1 make 4, 2 and 2 make 4. So that's a little check on your system there. Now, the next step, the final step, is to simplify. We might have to do this in a couple different iterations. Let's go ahead and do the first round here. When we multiply this, we've got 1. Let's just write this out in a super, super long way. 2x to the 4th means 2x times 2x times 2x times 2x. This one is going to go to 1. Anything to the 0th power is 1, so we can always forget about that guy. Now, if we multiply that 2 times 2 times 2 times 2, that's going to be 16x to the 4th. So this term is done. Great. We've only got 1, 2, 3, 4 more to go. This next term, if I write this out the really long way, that's going to be 4 times 2x times 2x times 2x times negative 3y. So now I've got to start multiplying. 4 times 2 is 8, 16, 32. 32 times 3 is going to be 96. So that's going to be 96. We got x, x, x. So I have 3 x's, and I've got a y. Now I'm going to check something here. I made one mistake. See if you can see it. And that's it. I forgot that minus sign. That minus sign is going to go right there. It's minus negative 3y. So don't forget your minus signs. Okay, we've got that term sorted out. Now this next one is going to be 6 times 2x times 2x times negative 3y times negative 3y. And when we go and simplify that, that's going to turn into 6 times 2 is 12, times 2 is 24, 24 times 9 is, let me think. That's going to be 216. And we've got a negative and a negative. The negative and the negative make a positive. And so now we have 216 x, x. We've got 2 x's and we've got 2 y's. Okay, now this next term right here, that is going to be 4 times 2x times 3y times 3y times 3y. And we multiply that out, we end up with 3 times 3 times 3 is 27, times 2 is 54, 54 times 4, what's that going to be? 54 times 4 is 216. So another 216, just by coincidence, 216 xy cubed. And check this out, this is I didn't write this down right, but this is a negative 3y, negative 3y, negative 3y. That's going to turn this into a negative term. And then the final one right here is going to be negative 3y times negative 3y times negative 3y times negative 3y. And if we do that and simplify it, it's going to be plus 81y to the 4th. And that's it. That is the simplified polynomial. So it's still a fair amount of work, but those are the steps for that.